So example 8.2.1, confidence interval for the population proportion using technology. So this is actually an example we looked at in the last chapter and had run a hypothesis test on. But in this case, again, we're wanting to actually estimate what this true population proportion value is. So research studying the effects of income levels on breastfeeding of infants hypothesizes that countries where the income level is lower have a higher rate of infant breastfeeding than higher income countries. It's known that in Germany, considered a high-income country by the World Bank, 22% of all babies are breastfed. In Tajikistan, considered a low-income country by the World Bank, researchers found that in a random sample of 500 new mothers, so here's our little n, that 125 were breastfeeding their infants. So find a 90% confidence interval for the proportion of all mothers in Tajikistan who breastfeed their infants. So again, we're going to follow through the steps since we're looking at a confidence interval, we're going to follow the acronym PANIC. So P for population parameter. So in this case, we are interested in estimating the proportion of all new mothers in Tajikistan who breastfeed their infants. That value we're not going to know, but we're going to get information from the random variable p hat, which is going to be the proportion of the sample, so of 500 new mothers in Tajikistan who breastfeed their infants. All right, every inferential procedure has its list of assumptions that need to be checked. Again, those are going to be listed on your cheat sheet, so you don't need to memorize them. You just need to know what the symbols stand for. So again, we need a simple random sample of size n. So again, they stated they took a random sample of 500 new mothers, so that's our little n here. For right now, for our qualitative data, we need each object to be able to go into exactly one of two categories. So in this case, either a new mother from Tajikistan breastfeeds or doesn't. So there's just two categories. And so now if we check the conditions to make sure that we can use the normal distribution, because again, one proportion z interval, the z stands for the z-scores from a normal distribution that will be used. Okay, so we're going to check that we have at least 10 objects in each category. And if we go back up here, this 125 that they gave us was x. So again, for qualitative data, we can either count the number of objects in a category, which is x, or look at the percentage of objects in a category, which would be p hat. Okay, 125 is definitely a count, so this is the value of the random variable x for qualitative data. All right, so our x value here is 125. That is definitely at least 10. And then n minus x would be 500 minus 125, and that also needs to be at least 10. And so if we do that mathematics, we get 375, and that is definitely at least 10 as well. And then cap n, they did not give us the population size here, so again, we're just going to assume that this is true. So no cap n given. So we're going to assume that it's big enough to be greater than or equal to 20 times little n. Again, it is not statistical practice that when you don't know some piece of information, you just assume something is true. But we do that in the case of cap n, because typically if it's not given, it means it's large, and it's large enough to be considered to be greater than or equal to 20 times little n. All right, so in this case, all of the conditions we just checked were so that we can use one proportion z interval. So the one meaning we have one set of sample data, proportions because we're dealing with qualitative data. We checked the conditions to use the normal distribution, so that's what the z-score p stands for. And now we're trying to do an interval procedure instead of a hypothesis test, so it ends in interval instead of test. All right, so our fourth step here is to find the point estimate and the interval estimate. So our point estimate, we don't know p, so our next best guess for that is the value of p hat. And so our formula for that is x out of n, which in this case was 125 out of the 500 surveyed. And so if we compute that, we get 0.25. So 25% of our sample of mothers breastfeed, and if we had to guess the population percentage and give a single number answer, we would say that we estimate that it's 25%. We know it's probably not that, which is why the interval estimates are typically given instead, with some, give and take around that point estimate of 0.25. All right, so to get the confidence interval for P, we're going to go on the calculator and we're going to go into stat and arrow over to tests and choose that 1 proportion Z interval. Next to X and N, we're going to put in 125 and 500. Next to the confidence level, we're going to put in 0.90 since they asked for a 90% confidence interval. And when we hit calculate, we get the endpoints on the output screen. So our confidence interval for P, we're going to use interval notation. Okay, so a rounded parentheses, and we're going to put 0. We'll round to maybe 3 decimal places. So how about 0.218, comma, and then our upper endpoint, we're going to put 0.282. So we're 90% confident that P is in this interval. So without context, I'm just going to write off to the side, we are 90% confident P is in this interval. So again, keep in mind we're doing inferences, so we are concluding about population. So this symbol is important here that it's a P and not a P hat. Okay, we don't need statistics to tell us P hat is in this interval. Okay, 0.25 is definitely between 0.218 and 0.282. Okay, what we're interested in is whether P, the proportion for the entire population, is actually in this interval. All right, so our last letter here, C, is a conclusion and context. So we are going to just take what we just wrote here. My computer's gone crazy. So the last step here is conclusion and context. So we're going to take what we wrote here. We are 90% confident P is in this interval, and just write that with the context of the problem now. So we're going to write here that we are 90% confident that the proportion of all new mothers in Tajikistan who breastfeed their infants is between 0.218 and 0.282. Okay, so in this statement, I'm just going to pick a highlighter here. So up here we have P, but if we scroll back up, we see that P stands for the proportion of all new mothers in Tajikistan who breastfeed their infants. So all we've done in this context is we've just said we are 90% confident, and where we have P, we have put what P stands for, which is the proportion of all new mothers in Tajikistan who breastfeed their infants is between, and then those two endpoints. All right, so one final thing with this interval. So the other thing that we could say here, instead of proportions, we can use the word percentage. So we could say we are 90% confident that the percentage of all new mothers in Tajikistan who breastfeed their infants, and then change the proportions to percentages, 21.8% and 28.2%. And sometimes these intervals, when we see them reported in newspapers and studies and so on, sometimes instead of an interval, they are given as the point estimate with the margin of error mentioned after the fact. So sometimes these intervals are reported as follows. So we estimate that 25%, so that was our value of P hat, of all new mothers in Tajikistan breastfeed their infants, and then parenthetically we have with a margin of error of about 3.2%. So that 3.2% came from, so if we take our endpoint that the calculator gave us at 28.2% and subtract the midpoint of 25%, that gap is 3.2. And same thing down here, if we take 25 minus 3.2%, we get the other endpoint, which is 21.8%. Okay, so again, our confidence interval for P ran from 21.8% to 28.2%, But we can also write that in this form, p hat give or take the margin of error, which in this case would be 25% give or take 3.2%.